right, so now we're working with the quadratic formula. All right, so we're going to work with this quadratic formula. And this quadratic is just a formula you have to memorize. And what it's giving you the two values, all right? And I'll kind of show you here. But when we have it in given, I talked about we're always giving these equations as ax squared plus a bx plus a c. And the idea is that we can always put these into an order of negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, it's not that bad. So for this equation, my value, my negative b would be negative 1. So it's kind of like my b here is a 1 that's implied there. And then plus or minus the square root of b squared, 1 squared is still 1, minus 4 times a, 4 times a is a 2 because the 2 is the coefficient of the x squared, times the c. And this is where we get a high one, which is okay, we'll figure it out. All right, times a negative 45. All over 2 times 2. All right, so we can work this out. So we have negative 1 plus or minus the square root of 1 minus. All right, so this is going to be plus 360 because 4 times 2 times a negative 45, negative 4, I'll see this as times 2 times negative 4 is a positive 360. Well, so what we really have here, I'm going to run out of space here, but 1 plus the square root of 361, because now I added the 1 to the 360 over 4. Well, the square root of 361 happens to be 19. So negative 1 plus or minus 19 all over 4. Sorry, I'm kind of got a lag here. So we're all over 4. Well, we could do that. Negative 1 plus 19 is 18 divided by 4. 18 divided by 4, we can just leave as 18 fourths. All right. Negative 1 minus 19 is negative 20 divided by 4. Negative 20 divided by 4 is 5. So our answers, and these are kind of more the answers or what you get if we had them here. It would be x minus 18 fourths and x minus 5. That's what we get when we factor. Okay, so remember that we kind of do that opposite, but the quadratic formula is really pretty powerful. It always kind of works, especially when we have that leading coefficient of a 2. So let's look at another one. Let's look at another quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, what I usually do is I usually take what's underneath my radical and I put that into my calculator. So in my calculator, I would put in 36 minus 4 times 2 times a negative 56. All right, I got the wrong answer already, of course. So 4 times 2 times 56. All right, plus 36, 484. All right, so what I have here now is I have the square root of 484 and I have this negative 6 over 4. Well, the square root of that happens to be 22. So negative 6 plus or minus 22 over 4. Negative 6 plus 22 would be negative 16 over 4, which is positive 16 over 4, which is positive 4. And then negative 6 minus 22 is negative 28 divided by 4 is negative 7. So what does this mean? It means that x minus 4 can be factored like that, and x plus 7. Okay? So this was actually one. You're like, wait a minute. It doesn't have a 2 or anything. How did I make this so difficult? Actually, this is one where I could have factored a 2 out of each and every term to begin with. So I could have factored out a 2 right there. And so what would have happened is I would have had the 2 out in front, and then I would have had x squared plus 3x minus 18. No, not 18. It has to be 28. Sorry. There. And then I can factor in that. This is much easier to factor because now my leading coefficient is a 2. So technically that factored to that. Okay? So, so now I want to bring this back to where we started. We started saying we have standard form a lot of times in a parabola. All right? So this would be our standard form. And if we wanted to graph this in standard form, we would say, oh, we just have to find the axis of symmetry and go from there. All right. But instead of that, what we want to do is we want to find the x-intercepts. So we want to take standard form and put it into intercept form, okay? To do that, what we do is we factor. So we want, in the end, this to be a y equals two values that are multiplied together, all right? So what we do is we say off to the side, what multiplies to give us a 2 and adds to give us a positive 3. So what two things multiply to give us 2, and when I add the same two numbers, I get a positive 3. The answers in my head is 1 and 2. 1 times 2 is 2. 1 plus 2 is 3. So here, I really can rewrite this original equation as x plus 1 and x plus 2. So I just rewrote it, and now I rewrote it in intercept form. So what I'm saying now is, you kind of ask yourself the question, to have y be 0, what would your x's be? All right, so you're asking yourself the question, what would your x's be in order to have the y be 0? Because the y is 0, and that's where it's crossing this x-axis, is where y is 0. All right, well, in order for x to be a 0, this would have to be a negative 1. In order for this grouping to be a 0, this would have to be a negative 2. So what we would find is this is one of the solutions at x equal negative 1. This is one of the solutions at x equal negative 2. And our equation, or our graph, if we had a graph, but what if we didn't do a graph, would look like this. This is our solutions, the negative 1 and the negative 2. That's what we could do if we said, okay, we're going to do this without ever graphing. All right, we have our solution. So let's look at another example. How do we put this into intercept form? How do I get it into the form of x here and it equals a value equals a value? All right, well, I have another example here. Let me look. I'm off to the side, and I'm going to say what two numbers, when I multiply, it gives me a negative 36. But yet when I add the same two numbers, I get a negative 5. 6 and 6 isn't going to work because that doesn't give me a negative 5. The next one I think of is a 9 and a 4. One of them has to be negative, for when I multiply them, I get a negative 36. So let's start with the negative 9. Is negative 9 and a positive 4 a negative 5? Yes, it is. So I have here negative 9 and positive 4. So what this is saying is the solutions, or what makes it 0, would be y is 0, x equals a 9, and x equals a negative 4. Okay? Those are my solutions to this equation. That means that's where it crosses the x-axis, and we consider that the solutions to the equations. It's just kind of our mathematical way of saying, hey, at 9, 0, we're going to cross that x-axis, and at negative 4, 0, we're going to cross that x-axis. Let me see if I have another one. I don't know. Yes, I did. All right, we have another one here. All right, kind of reminding ourselves, again, same idea. We want it to be equal to, in this intercept form, and kind of had to remind ourselves that what we really have to do when we have just two terms, one way we do it is we think of it as 0 times x. All right, so now we're saying to ourselves off to the side, what two values multiply to give me a negative 81, but then when I add the same values, I get 0. Well, it has to be a positive 9 and a negative 9. All right, so what we have here is x minus 9, x plus 9. So my solutions would be either that x equals a positive 9 or that x equals a negative 9. Okay, and those are my solutions there. Now, if we get a really difficult equation here, and I don't know, I'm going to get kind of a crazy answer here. Y equals, because I'm just going to make up numbers, 3x squared plus 2x minus 7. All right. Wow, that would be hard to graph. All right, harder to factor. So what I'm going to do instead is I'm going to use that quadratic formula. I'm going to go off to the head side and say to myself, okay, I know my quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I could do that. All right, so then I'm going to say to myself, negative b plus or minus the square root of b squared minus 4ac all over 2a. Know that this may not always look pretty. In other words, it might not always come out to be a constant answer. We might still have that radical in there, that square root, and that's okay. So what I have here underneath, I have -4 times a -7, which would give me a -28 times the 3. What's 24, 6, 7, 8, 84, and we have 4 plus the 84, so we have 88 here, all over 6. Now, actually, what I have here is I have two answers. I know it doesn't always look like two answers when it's in this form, but I do. Because of this plus minus, it's two answers. It's 2 plus the square root of 88 over 6 and 2 minus the square root of 88 over 6. This is okay for your two solutions. It's okay to leave it like this when you say, I don't know what the square root of 88 is. It doesn't have a nice square root. It's okay to leave it like this. All right. And that's a perfectly good answer. They accept this answer on any AP test, and it would be just fine. So hopefully you have a better sense of why we need to factor, why it's so important, how it has to do with parabolas, and then how we use it to solve these equations. It's a really important concept. I highly recommend that you continue to look for other solving quadratic videos online.